Okay, so it's going to be y dy equals x squared dx, yes? And then what do we do to each side to solve? We integrate. And what is the integral of y? Y squared over 2. Don't do a plus c. We're going to put it all on the right-hand side. What is the antiderivative of x squared? Over 3. Now I do my plus c. That's the differential equation. And for ones where you can solve easily, I'll just tell you in the future for differential equations, I get to stop there if I want to. Unfortunately, I am trained as a calculus teacher to always solve for y. So we're going to finish this up. We're going to go ahead and we're going to finish this up. Right? Oh, wait, we have to find c. We have to find it at this point. Oh, never mind. We're not quite ready for that. So we have to plug this in and find c, don't we? And you do want to put it in this form. You don't want to solve yet. You want to plug it into as the equation comes out when you integrate it. So our y is -5. When I square it, right? So I'm going to put in -5 squared over 2 equals, my x was 3, so I'm going to go 3 cubed over 3 plus 9. This becomes 25 halves. That's 3 cubed over 3. That means it's 3 squared, which is 9. Oh, I wrote, it's plus c. I was already writing what it was. Hang on. C. I was already processing that in my head. Plus c, right? Well, if I do this in halves, is that 18 halves? Subtract that from 25. You get, so it's 25 halves minus 18 halves equals c, which equals 7 halves. Right? So what's my equation? You haven't finished yet until you plug it in. So it's y squared over 2. And then it's going to equal x cubed over 3 plus 7 halves. Right? So first we're going to get rid of this 2, or we're going to multiply everything by 2. So y squared equals 2/3 x cubed plus 7. And then how do I finally solve for y? Square root of both sides. Is that going to be a positive and negative root? Yes? So y is equal to plus or minus the square root of 2/3 x cubed plus 7. And now we have to evaluate. Our point was 3, -5. Which one of those do I want? Do I want the positive root or the negative one? If my point is 3, -5, I want the negative one. You have to think a little bit. If the y is negative, if I change this to positive, the positive root is not going to produce a negative y. So for this specific one, if I want to solve for y, it is y equals to negative square root of 2/3 x squared plus 7 because of the negative.
Einfach easy.
Oh, it is. That's an example of a problem. Shall we try some more? Because these get much more interesting, because before I kept saying that you were going to separate the variables. Now are all my equations implicit and you have to separate the variables? Before, pretty much you were just integrating functions of x. Now they're not functions. They are equations that are a mixture of x's and y's. Okay, I need to add a page. Hang on a second. Let me see this page. I'm going to look at the view page. Paper size. Letter. Let me see what happens when I add a page. Oh, good, it worked. All right, so for my second example, and the best thing to do on this is just do examples. Because you know the technique, you just don't realize you know it. We're just applying it to a new kind of problem. This is dy dx equals to 6x squared y. Implicit, right? Got x's and y's. I want you to solve this at 0, 4. Is that an initial value? Because it's times 0. Whenever they say initial value problem, they mean times 0. You're going to solve the differential equation. That's all they're going to say. If they say solve the differential equation, are you going to go till you get y? That means you want y equals. Sometimes they will say solve for y. But if they say solve the differential equation, it means integrate it till you get to y. All right, now we're going to separate it first. Are we going to move all the y's to the left and all the x's, including the dx, to the right? So we end up, this one's the 1 over y, dy equals 6x squared dx. I'm going to integrate both sides. What's the integral of 1 over y? Natural log absolute value of y equals 6 is the coefficient. Integrate x squared for me. What do you get? X cubed over 3 plus c. Yes? Okay. Simplify that. Do you get 2x cubed plus c? I now have natural log absolute value of y equals 2 times x cubed plus c, and I want to solve for y. Have I solved for y yet? No. How do I undo natural log? Oops, hang on. I meant to get red. I'm going to raise this. That's going to become the power of the exponential function. If I take it both sides, now here's the trick. You must show this step to me. I need to see that you understand the math. I understand that you can memorize crap, but you need to understand this concept because this is so powerful. We use it. I use it all the time in my differential equations class. I used it all the time when I was an engineer. Whenever you have a base to powers that are sums, is that the same as saying it is e to the 2x cubed times e to the c? Notice it is times. These are times. If I have the same base and I have different powers, do I sum the powers to simplify? I want to get this by itself. Is that just a number? Is e to a number just a number? So it's just, so if we call this coefficient 1, then this whole thing is just big C. So what do I end up with? Is this going to undo? And I'm going to get y equals to c e to the 2x cubed. And this is going to be something you're going to see over and over and over and over in science and engineering. And you will see it over and over and over in this class, in this chapter. Now, we need to know what C is, and we are at the point 0, 4, which makes this really easy to evaluate. This becomes 4 equals C e to the 0 power. What's e to the 0 power? 1. So what does C equal? 4. So my final equation, so this is the general equation. When you get to differential equations, that's the general solution to the differential equation. The particular solution, or in this case the initial value solution, is y equals to 4 e to the 2x cubed. And we are done. That wasn't too bad. Right? Is this the most important step you're going to learn? I know it is on the AP test, but I know for a fact, engineering, science, anybody who has to take differential equations in college, that trick is going to so come in handy. Okay. And now, for example, we're going to go to another page. Example 3. And then y'all get to work and ask me questions. Example 3 is, I'm going to do dy dx is equal to x times y over x squared plus 2. And I'm going to say, find the general solution of the differential equation. Is that another way to say the same thing? Find the general solution to the differential equation, or for the differential equation. Do we have to separate the variables? Absolutely. Move all the y's to the left, all the x's, including the dx to the right. Am I going to end up with 1 over y dy equals x over x squared plus, go away, not now. I'll pick that. There we go. Dx. Yes? Integrate both sides. Repeat, rinse, wash. Yeah? What's the antiderivative of 1 over y? Natural log. Need to get used to that. Okay, for this one, am I going to need u sub? I don't, but you do. If you don't, that's fine, but if you do need it, this is my u. du is equal to 2x dx. I clearly do not have the 2, so I need 1/2 du equals x dx. So this becomes 1/2 integral of 1 over u du. OMG, I'm going to get natural logs on both sides. Isn't that awesome? It is, actually. So this equals 1/2 natural log absolute value. What was my u? X squared plus 2. So I really didn't need the absolute value because that's always positive, right? If you're paranoid, can you just leave the absolute values? There's nothing wrong. If you want to leave it as absolute value even though it's positive, go ahead. Plus c. Do I want absolute value? Do I want natural log absolute value of y? Absolutely not. So what do? My whole e trick. E raised to the power of the right side, e raised to the power of the left side. E undoes natural log. I get y equals, for this other side, I'm going to be really clever. I'm going to take this because I know my log properties, and I'm going to put it as the power for this thing, and I'm going to break this thing up, and it's become e of square root of x squared plus 2 times e to the c. That's c1. So this equals c e to the square root of x squared plus 2. Oh, wait. I did that. I was getting too clever. I forgot my natural log. I was doing that on purpose so that you would see that it's, hang on. And then I got clever. So that undoes, and you're right. So you get c square root of x squared plus 2. Thank you. So y equals to some constant square root of x squared plus 2 is my final particular solution. And that's solving differential equations. You really need to practice this weekend, because next week when we do Newton's law of cooling and exponential growth and decay, we will be using these tricks all over the place. And then you remember how you did partial fractions? Eventually we'll get to logistic growth, and for logistic growth, you have to do partial fraction decomposition. So this chapter 8, we use everything we learned in chapter 7, pretty much everything you've learned so far.